Here is a final example. So here we have a flu epidemic on a college campus of 4,000 students, begins with 12 cases, and after 1 week has grown to 100 cases. So find a formula for the size of the epidemic after t weeks, and then use your answer to estimate the size of the epidemic after 2 weeks. The one thing to kind of notice is that we do have a maximum. Okay, so we do have a maximum here. So the college is at 4,000 students, okay? And you can kind of imagine that that this thing is growing. So in the beginning, we're gonna have a couple of people. We see that it begins at 12 cases. It doesn't begin at 0. So you can see that this is growing with the present size and also with the max and proportional to the maximum size. So this is gonna be a logistic one. Is logistic. So what we know about logistic is that y prime is equal to ay m minus y. That's what logistic is. And the solution to this logistic equation, differential equation, is just going to be y equals m over 1 plus c e to the negative a mt. Okay, so we already know what the solution is. We don't need to be doing the integration over and over again. It'll be really messy. So a couple things that we know is that in the beginning it starts off with 12 cases, so we know that y of 0 equals 12. And then we also know that after the first week we have 100 cases. Okay, so we know that as well. So now what we want to be able to do is let's plug in everything that we know. So we know that y prime is equal to, we don't know the rate at which this is increasing, so we don't know that. Y minus m, we know that there's 4,000 students, minus y. Okay, so if I go ahead and put it in my solution, you're gonna get 4,000 divided by 1 plus c, we don't know what c is, e to the negative a times 4,000 times t. Okay, all right, so now what we want to do is we should probably figure out what the value of a is. So I think the easiest one to plug in is using our first initial condition, y0 equals 12. Okay, so let's go ahead and plug that in. So we have y of 0 equals 4,000 divided by 1 plus c e to the negative a 4,000 times 0, because we're plugging in 0. Okay, so y of 0 is equal to 12, so 12 is equal to 4,000 divided by 1 plus c. Well, my a went away, it's fine, e to the 0, and e to the 0 is just 1. So that's fine. I mean, the a went away. Maybe by plugging in the second initial condition, I'll figure out what a is. But luckily, maybe I can figure out what c is too. So I'm going to move that over. So 12 times 1 plus c equals 4,000. I'm going to divide by 12 to both sides. So I'm going to have 1 plus c is equal to 1,000 over 3. Okay, I'm going to subtract from 1. So I'm going to have c is equal to 997 over 3, which is basically approximately 332.3. Okay, so that's what I have. So let me go ahead and plug this into my differential to my solution. So we have that y is equal to 4,000 over 1 plus 332.3 e to the negative a 4,000 times t. Okay, so we're still not done because we still need to figure out what a is. So luckily we figured out what c was. So now let's use our second initial condition. So we're gonna plug in y1 now, y of 1. So y of 1, y of 1 is equal to 4,000 divided by 1 plus 332.3 e to the negative a 4,000, and then we're gonna plug in 1 in there. So y of 1 is equal to how much? 100. So this is just 100 is equal to 4,000 divided by 1 plus 332.3 e to the negative 4,000 a. Okay, now let's move the denominator over to the other side. So this guy's going to go over to the other side. Okay, I'm going to multiply it. So I have 100 times 1 plus 332.3 e to the negative 4,000. A is equal to 4,000. Okay, I'm going to divide by 100. And I'm going to have 1 plus 332.3 e to the negative 4,000. A equals 40. And now all we have to do is solve this exponential equation. So now let me first subtract by 1. Okay, so subtracting it by 1. So what I'm going to get is 332.3 e to the negative 4,000a is equal to 39. I'm going to divide by this 332.3. 2.3. So I have e to the negative 4,000a is equal to 1.11736. Okay. And then what I'm going to do is just take the natural log to both sides. So I'm going to have negative 4,000a is equal to the natural log of 0.11736. And then just divide this by negative 4,000. So A is approximately equal to 0.000535. Okay, so that's what we have. So all we have to do is just plug all of that in. So we have y is equal to, into my original, we had 4,000 over 1 plus e to the negative a, which is in this case 0.000535. Multiply this by 4,000, and then you have a t. So we have 4,000 divided by 1 plus e to the negative, and I multiply that out, I'm going to get 2.142 t. Okay, so there's my solution. Took a lot of work, so it's a lot of algebra. Now, the only thing that we're left to find is what is the size of the epidemic after 2 weeks. So all we have to do for this problem is just plug in 2. So y of 2 is going to be equal to 4,000 divided by 1 plus e to the negative 2.142 times 2. And this is going to give me approximately 717 cases. This is what I ended up getting after 2 weeks. Okay, so yes, there's a lot of algebra. This is probably the most algebra that you might have to do. And that's mainly because you have these exponential things, but yeah, overall, it's just a lot of algebra. The calculus itself, there really is no calculus here because the calculus is already done. So everything else is just an algebra problem.